Okay, so I want to go through and fill this in. It'll be kind of a good review as we're going through, since it's been, a few days since we've been together. So this is the in-class practice. So let's fill in these blanks. So it says forces are vectors, which means that they have both blank, and units. What are the two things besides units that a vector has to have? Think back to the villain vector.
Direction and magnitude.
Good, so you're gonna have to have direction and magnitude. Everything's been really slow. I was hoping over break my technology would get rested, but no, it's still pretty jumpy. All right, so magnitude, which is really just our number, right? And direction. And obviously, anything with a number has to have a unit, except for slope. Okay, so it says the net force is going to be the combination of all the forces. So this is like when we talked about our force diagrams. We looked at the forces in every direction and what was happening. What we're left with is called the resultant force or the net force. Kind of goes by the same name. And so when we have forces that act in the same direction like this, these two movers, 20 newtons to the right and 22 newtons to the right, what are we going to do with those vectors or with those force values? Are we going to add them or are we going to subtract them? They're going in the same direction? Add them. Thanks, Dewey. Combine them, right? You add them all up. If something is working, so like this force, if you'd have 20 newtons to the right and 22 to the right, we'd end up with 42 newtons to the right. If we have forces that are in opposite directions, like here, right, this little guy's pushing with 100 newtons to the right, 150 to the left, what are we going to do there? Somebody else. There's 22 of you. Subtract them. Good, thank you. And I do appreciate people offering to answer multiple times, but trying not to make you do all the work. All right, so if we have 100 and minus 150, we're going to be left with 50 newtons, and then which direction? How do we know the direction to apply? Rory, what do you think? Good. 150 is bigger, right? So that's going to kind of win that kind of balance, that pushing back and forth. So 150 newtons to the left. Here we have balanced forces, right? They're working in opposite directions. So we're going to get no change in motion, right? It looks like they're pretty equal there. So make sure you have those things filled in. Again, just kind of as a quick review before we get into our details here. So we have an equation, right? We have a triangle that matches that equation. Here, anything, again, over this line is going to be division. So if we're solving for acceleration, I can cover up acceleration, and I'll get force divided by mass. If I'm needing to solve for mass, I'll get force divided by acceleration. And my standard equation, if I'm solving for force, is going to be mass times acceleration. Okay? So our equation itself, the standard equation for Newton's second law is force equals mass times acceleration. You can either have it like that, or if you would rather put in the multiplication sign. A lot of times at this point in algebra, you guys are so used to not putting the multiplication sign, or if you even want to put the dot, whatever you're comfortable with is fine with me. I typically kind of just do it like that. Okay, so for all forces, what is the unit? Who's the one that came up with the 3 laws? Newton, right? So the unit of force is going to be the Newton. And we can just use the capital N for that. There's a lot of different mass units, but the one specifically that we have to use is what? Anybody remember? Charlie, what is it?
Kilogram.
It's going to be the kilogram, not the gram, not the milligram, not the hectogram, decagram, decigram, none of those. Has to be the kilogram. And then for our acceleration, what did we say the specific one had to be? It can't be the kilometer per hour squared, can't be the centimeter per minute squared. What did we say it has to be? Perfect. Meter per second squared. Did you guys figure I was just gonna wait you out? Okay. All right. This is awesome though. There's no guesswork. So if you're solving for mass, you already know what the units are gonna be. You don't have to read the problem and wait to see is it a kilogram, is it a gram, is it a milligram, right? You know because it's always gonna be the kilogram for this type of problem. Same thing with our acceleration and same thing with our force. They're given. We always know what they are. Okay, and it's really because a kilogram specifically times a meter per second squared is what our Newton is. So we can't substitute those for anything else, or we wouldn't be getting the Newton. We'd be getting a big version of the Newton or a small version of the Newton, but there is no such thing. So we have to follow exactly what what makes that Newton up, which is the kilogram and the meter per second squared, right? I put in here round or don't round, it's up to you, so whatever you're comfortable with. Okay, so let's do the first one together here at the bottom of the page. We're gonna follow our same strategy that we've used all year long. So a baseball with a mass of 0.8 kilograms is given an acceleration of 20 meters per second squared. How much force was applied to the ball? So give me something that I need to underline that is given to us in this problem. Ethan, what's something that we need to underline? Ethan, you with me? What's something we need to underline? What's given to us? You see any information that they tell us right off the bat? Perfect, so we're gonna underline that, right? That's my mass. Anthony, what else is given? That's my acceleration. And then Dylan, what are we solving for?
Let's see, we're doing mass times acceleration.
Right, but what is the actual variable that we're solving for? What's it say in this last sentence?
Force.
Perfect. Okay, so force is going to be my unknown, right? We know that the mass is going to be 0.8, and we know that the acceleration is going to be 20. All right, so now we're going to use the triangle to set up our equation, which we're solving for force, so that's our standard equation, right? You could cover it up, right? You could cover up force, and it'll show you mass times acceleration. All right, so now I'm just going to plug in. My mass is 0.8, and my acceleration is 20. So when you do that math, what do you get? What do you get, Charles? I just called you Charles, didn't I? That's gonna be bad, because Charles is right there. I'm gonna be calling you Charles, your brother. Dang it. All right. 16, thank you. Sorry, that's gonna happen more, probably. Dang it. It's too late in the year. I do not want to insult you by calling you your brother. Okay, so 16, and then what's going to be our units? What's it going to be? What do you think, Cheyenne? We're solving for force. Not for force. What did you have written in up here? Our unit for force is always going to be the Newton. Good. Okay, so 16 newtons. So really there's nothing all that unusual about how we're doing this. We have the same process, we have the same type of equation, we have the same triangle that we get to use. Let's do this a little. There we go. Okay, so a golf ball is hit with a force of 15 newtons and travels with an acceleration of 25 meters per second squared. What is the mass of the golf ball? So, John, what is a piece of information in this problem that's given to us?
15 newtons.
Very good. So, I'm going to underline 15 newtons And, let's see, Kate, what else is given?
Acceleration is 25, but can I also borrow a pencil? Mine out of lead.
Check over there. But, yeah, by the pencil sharpener. And then what are we gonna solve for here, Michaela? Okay, so I'm gonna put my question mark for my mass, fill in my force, which is 15, and my acceleration, which is 25. Okay, so now I'm solving for mass. So I do need to go over to my triangle, right? If I have mass covered up, what's it tell me my equation's gonna be? What's this gonna be? Cole, what do you think?
Force divided by acceleration.
Good. So we're gonna do that. Force over acceleration. So now I'm just gonna plug in. My mass is still unknown. My force was 15 and my acceleration was 25. What do you get when you do that division? Fifteen divided by 25. Dylan, what'd you get?
Does the bottom go on top with the,
Put the top number in first.
you get 0.6.
Okay, Michaela, did you get 0.6 also? Yeah. Good deal. All right. So we get 0.6. And that makes sense, right? Because this is going to be a number that's smaller than 1. Like, so if you use your kind of common sense, if you get a number greater than 1, you probably entered this in wrong. Because obviously looking at this, you can see, hopefully, that it's not a whole number, right? Your top number is smaller, so you're going to end up with a decimal answer. So if you ended up with where you put 25 divided by 15 and you got a whole number, or, you know, something greater than a decimal, then you know you probably flipped them and did it wrong, right? So that's one way to check yourself. So what are our units going to be for mass? What will that be, Charles, for real Charles this time? Wait a minute, we're solving for mass though. What are our units for mass? If you want double check, because that's why it's on the paper. Perfect, kilogram. There we go. Okay, let's set one up for acceleration. So it says a force of 1,500 newtons is applied to a 1,000 kilogram car. What is the acceleration? So that's what we're solving for. That's our unknown. Give me the two pieces of information that we should underline. Maddie, give me one.
1,000, 1,500 newtons.
Okay, that's gonna be our force. And let's see, Breeze, give me something else.
1,000 kilograms.
Okay, so which one is my force? Which one is my force? Audrey?
15,000.
100. Okay, and then that leaves our mass as our 1,000. All right, so we're setting up for acceleration. So again, I go to my handy dandy triangle, and it says to do what for my equation? What's that gonna be? Austin, what do you think?
Force divided by mass.
Good. All right, so acceleration is gonna be 1,500 divided by 1,000. And here we should not get a number that's less than 1 because our bigger number is on top. So what are we gonna get? What'd you have, Dylan?
1.5.
Very nice. 1.5, and we're solving for acceleration. So, Selena, what are gonna be the units for acceleration? And if you're not sure, remember you have it marked on the front of your paper there. We're not solving for mass this time. We're solving for acceleration. So do you see somewhere else where acceleration units are given, or do you see where we filled that in? What is it? Yep, what are the units that go with it? Yep, we have the meter, But what else goes with it? Wasn't there some more with it? Yep. And then we have to include that little square, right? Good, so meter per second squared. So now you have an example for all three variables. So if you would need like to look back at how to do one, you have a nice example. What I would like you to do is, I want to show you something real quick. Here in a minute, I'm going to give you your assignment paper. I want you to have these things filled in. The unit for force, the unit for mass, and the unit for acceleration, right? You need to fill those in. I'm giving you points for that. I want the equation filled in here as well, because I want you to have this here so when you're working, you can have it right there in front of you, all right? So I am going to be looking for those 4 blanks, and I will tell you those are the 4 biggest missed points every year on this assignment, all right? People forget to fill those in. And it says round or don't round, I don't care. So you're gonna get that here in a minute, but what I would like you to do is finish number 6 and 7 on your paper that you have and bring it up to show me, and when you show me that you've got it, then you come up and get your assignment paper. So you're doing 6 and 7 on the white paper, and then you will come up and get your assignment paper.